going to solve for the value of x from this nice Olympiad exponential equation. And the given equation is 4 to power x minus 12 is equal to 0. Then we are asked to solve for the value of x that will satisfy this equation. So the first thing we're going to do, as you can see, this negative 12 is constant. We're going to take it to the right hand side of the equation. We're going to have 4 raised to the power of x is equal to 12, because whenever negative number cross an equality sign become positive. So the next thing we're going to do, if you look at the base in the left hand side is 4, and in the right hand side we have 12. So there's no way we can make the base to be the same. So therefore, we're going to take the log of both sides, either to base 4 because the variable is in the power of 4, or log of both sides to base 10. But in this video, we're going to take the log of both sides to base 10. So we're going to have log of 4 to power x, which is equal to log of 12. So the next thing we're going to do is to recall power property of logarithm. This power x is going to go back to multiply the log. This is one of the property of logarithm. So we're going to have x log 4, which is equal to log of 12. So the next step is to divide both sides by the coefficient of x, which is log 4. So we divide the left hand side by log 4 and also the right hand side by log 4. So that this log 4 is going to cancel this log 4. We are left with only x in the left hand side, which is equal to log 12. And in the denominator, we have log 4. Do you know that we can write this 12 as 4 multiplied by 3, then everything all over log of 4. Now we're going to simplify further. Recall that when we have log of a multiplied by b, this is the same as log of a plus log of b. So this is one of the property of logarithm we are going to apply to the numerator in the right hand side. So that we have x now will be equal to log of 4 plus log of 3. So we write this in this form. So everything will be over log of 4. So the next step, as you can see, this denominator we have log 4, and in the numerator we have log 4 plus log 3. So each term in the numerator can share this power. So this is going to be what? X will be equal to log 4 over log 4, then plus log 3 over log 4. This is equivalent to this. So the next step we're going to do, as you can see, log 4 will divide log 4, which is going to give us 1. So x now will be equal to this divided by this is going to be 1, then plus. Then in here, we're going to recall one of the property of logarithm again. That see that when we have log of a over log of b, changing of base, this is the same as log of a to the base of b. So as you can see, here is in this form. So we're going to convert it to this form. So a represent 3, b represent 4. So the whole of this is going to be what? Log of 3 to the base of 4. So here is the value of x that will satisfy this equation. But for you to get the numerical value of x, when you press calculator, log of 3 to the base of 4, you are going to have 0.792. Then add it to 1, is going to be approximately 1.792. So this is the numerical value of x. So for us to confirm that what we solve is correct, we need to check by substituting this value of x back to the original equation, which is what? 4 to power x minus 12 is equal to 0. So the original equation is given as 4 raised to the power of x minus 12, which is equal to 0. So in place of x, we are going to replace 1.792. We are going to have 4 raised to the power of 1.792 minus 12. So we're going to see whether this will give us 0. So when you press calculator again, 4 raised to the power of 1.792 is going to give us 11.99, which is approximately 12. And 12 minus 12, of course, is going to give us 0. So therefore, the left hand side is the same as the right hand side when we substitute the value of x as approximately 1.792. So therefore, the value of x can either be 1 plus log of 3 to base 4 or approximately 1.794. Thank you for watching and please follow us for more video like this.